Okay, so over here we have question number 22. Right, so for question number 22, we have this two equation given y and also x. Okay, then we have to find the value of t when 1 minus dy dx minus the second derivative squared equals to 0. Okay, so first, when we have these two equations, let us take this out first. Okay, we have y is equals to exponent t plus exponent negative t plus 2. Okay, so we can get our dy dt. So dy dt is equals to exponent t minus exponent negative t. So if you rearrange this, that will be exponent t minus 1 over exponent t. Okay, and then we have the second equation. We have x equals to exponent negative t plus 2. So our dx dt, okay, so our dx dt is given by negative e negative t. Okay, so this one is dx dt. Now to get to our, so in our equation that we need to prove here, we need to find our dy dx and also the second derivative. So first let us try to find our first derivative. So dy dx, okay, is given by we have to differentiate this. We're gonna get dy dt times with dt over dx. So we need to get dt dx. Over here we have dx dt. So dt dx is basically the inverse of this. So if just now we write this back in terms of fraction, that will be negative 1 over exponent t. So dt dx over here will be just negative of exponent t. So substitute these two value of dy dt and dt dx in our chain rule over here. So dy dt is exponent t minus 1 over exponent t. Okay, and then we have to multiply with negative exponent t. Okay, so multiplying this, if we simplify this one first, we're going to have e exponent t minus, sorry, this one will be exponent 2t. Okay, so equalize your denominator, minus 1. Okay, and then over exponent t times with negative exponent t. Okay, so we will have that our dy dx is equals to, if we simplify, we're going to get 1. Okay, we're gonna have 1 plus with, sorry, 1 minus with, because we expand this, 1 minus exponent 2t over here. Okay, so you have to expand this term first. Okay, expand these two terms and then you divide by exponent t. So we're gonna get dy dx equals to 1 minus exponent 2t. Okay, so for our second derivative, what we're gonna need is, okay, so you have to check your second derivative, you will need our, okay, so let's do the second derivative on top here, d2y over dx square. You have to differentiate again, sorry, d dt. Okay, you have to differentiate again our dy dx, dy over dx, and then you have to multiply with dt over dx. So this is the chain rule for the second derivative, right? And then what we're gonna have here is differentiate our dy dx. Okay, so dy dx is given by 1 minus exponent 2t, and then times with dt dx, which is negative exponent t over here. Okay, so differentiate this, we're gonna get negative 2 exponent 2t. Okay, and then times with negative exponent t over here. Okay, that will give us 2 exponent 3t. Okay, exponent 3t. So in this question, we need to find our equation over here. We need to use this equation over here to get to the value of t. Okay, so by taking that, we understand that, okay, if we take if you substitute the information that we have in our equation, so we will have 1 minus, okay, so dy dx minus with our second derivative d2y over dx squared, okay, that is equals to 0. Okay, So substitute all the values that we have. Dy dx is 1 minus exponent 2t. Okay, and then our second derivative is 2 exponent 3t. Okay, we have squared over here. Squared equals to 0. Okay, so simplifying this, we're gonna get exponent 2t. Okay, and then minus with 4 exponent 60, that is equals to 0. So we're gonna have two values over here. We're gonna have, we can factorize this out, exponent 2t. So we're gonna have 1 minus 4 exponent 40, that is equals to 0. So by taking this, we have two answers over here. We have exponent 2t equals to 0. So the answer is undefined. Okay, and then you will get that 1 minus 4 exponent 40 equals to 0. So by rearranging, you're gonna have 40. Okay, so if we take ln, we're gonna have over here that, okay, let's take this one, exponent 40 is equals to 1 over 4. Okay, and then we're gonna have that t is equals to 1 over 4. Okay, ln 1 over 4. Okay, by taking ln on both sides over here, then we're gonna get the value of our t over here. Right, so the answer over here will be t equals to 4 ln, 1 over 4 ln 1 over 4. Then the answer is equals to question A for 22. Alright, so let's proceed to the next question. Question number 23 over here. So for question number 23, we have that dx dt equals to, given by, so the side of ice cube is decreasing at the rate of 5 centimeter per second. Okay, so when it says decreasing, so the keyword over here is decreasing, right? So we can write down that dx over dt is equals to negative 5, okay, cm per second, because it is decreasing. So what we need to find is our dv dt. Okay, so basically we're going to check here that our v is given by 3x squared, so the volume of an ice cube, right? So ice cube is, if one side is x, then the value is given by, the value is x cube over here, so when you differentiate v, then you're gonna get 3x squared. Okay, dv dx will be 3x squared over here. Okay, so this is our dv dx. Now we want to find dv dt. So to get to our dv dt, we understand that we need to take out our chain rule. Okay, so dv, and down here we have dt. So we already have the information for dx dt. So down here also we'll put our dx. Okay, so dv dx is given by 3x squared times dx dt. So dx dt is negative 5. Alright, and then we already know that we want to find this rate when the side is equals to 20. So you boleh masuk directly 20 squared over here times negative 5. Okay, so you just use a calculator, and then you're going to get that the value for dv dt is equals to negative 6,000. Okay, so 6,000 cm cube per second over here. Cm cube per second. So that is answer B for question number 23. Okay, so the next one for question number 24. The highlight over here is, okay, you are given this equation hx and also kx, alright, and you need to determine which of the following statements are false. Okay, so remember that we want to check for the false statement over here, not the correct statement. Alright, so what we're going to do here is, because we want to check for h composite k, so we will do the composite function first. Okay, so h composite k of x is equals to, when you substitute the function of kx in your h functions. Okay, so that is given by modulus of 2. Okay, and then we're going to substitute kx over here. Alright, and then plus 5. Okay, so 2kx plus 5, and then substitute with the function of k, which is x minus 3 and then plus 5 over here. Okay, so dah substitute dekat sini. When you expand this, you're gonna get 2x minus 6 plus 5, so that will give you 2x minus 1. So this is the composite for h of k. Okay, hkx, composite h and k. Alright, so look at the next statement that we have that is related to the domain and range and also the graph of this function. Okay, since this is an absolute value function, we understand that the asymptote or the minimum point, the vertex will be at 2x minus 1 equals to 0. Okay, so if we check from this one, 2x minus 1 is equals to 0, x is equals to 1 over 2. So actually this graph is correct. That is how we sketch our graph. Okay, we're gonna have it over here. Okay, so that we touch at 1 over 2. Okay, our graph here we touch at 1 over 2. And then because we want to also check if this is a one-to-one function, so we're going to do our horizontal line test. So if we take a line over here, so we can see that it touched our graph at 2 points. So it is not a one-to-one function. So we can already remove the statement. Sorry, not remove. We can already